Hello and welcome to Sustain, the podcast where we talk about sustaining open source for the long haul. Who are we? Where do we come from? Where are we going? How open is my research? Excellent questions that we're going to be covering today. Before I introduce our guests, I want to make sure you know who the other voices are on this podcast. I am, of course, Richard Littauer, and I'm actually the only voice. I am the solo host today. Really excited to be here, so this is going to be great. I am joined today by Richard J. Acton, calling in from Cambridge. Richard, how are you doing?
Hello, I'm great, thank you. Thanks for having me on.
Tell me about what you do. I know you're a researcher at a large institute, the Babrahams Institute, I believe, near Cambridge.
The Babraham Institute, yes. So I'm employed by a research consortium called the Human Developmental Biology Initiative as their research data outputs manager. And yeah, this sort of project, this checklist thing, came out of some work I was doing, writing guidance for the researchers in that consortium for their research software outputs as a type of data output, as it were. It got a little bit out of hand, grew larger than the original scope of what I was expecting. So here I am.
So this is obviously an open source podcast, not necessarily just an academic research podcast. So tell us, how did you get into open source and what do you do there before we get into the checklist itself?
Right. Yeah, I mean, so I'm not really a software developer per se. I'm a bioinformatician, so I'm not like an engineer in the research software engineering side of things. I write the occasional script and analysis pipeline, and I'm a biologist by training. And I got into open source, I suppose, as a byproduct of my bioinformatics training. Right, I learned a lot more about Linux and open source software through that, and started running it on my own systems, and got very much into the sort of political economy of software side of things. And I'm paid up member of the FSFE and very much in favor of things like public money for public code and those sorts of questions. But the open science angle on it as well is, I think, very important. That matters a lot to me. I'm very interested in the quality and the reproducibility of our work. So the software being an integral part of modern research means that it needs to be open in order to be reproducible effectively. So that's my into open source software, as it were.
It makes sense to me. You're preaching to the choir. Tell me about how your checklist that we have help with this.
The checklist came about because I didn't think that we had a really good guidance for researchers who are producing code which is not necessarily of a conventional production code type stuff, right? So you've normally got like a software package that you're thinking about maintaining. But for a lot of researchers, they're writing one-off analysis code or some scripts that do a particular thing for a particular research output or a particular paper. But then there are other things like bioinformatics tools with long pipelines of stuff that string together a bunch of different components. And so I ended up sort of breaking it out into a little taxonomy of different research software outputs. You've got those records of specific analyses. You've got like web-based services that maybe serve a database of some kind. And then you've got your sort of more generic tools, which might be like a unitary software package or a multi-plot workflow like a pipeline. And the existing literature on this is a bunch of sort of long policy documents of writing research and software management plans that are not necessarily very approachable for researchers, but even not necessarily the easiest thing for software engineers to get into either. So unless you're going out of your way to go and read those policy documents, I thought I'd try and make it a little bit more accessible. I'd seen some similar work from the image data and image analysis community, this checklist development process. So I thought maybe I can do this in the form of a checklist. And for software, rather than being like a big document, you stick in a PDF, just something that you can drop in your repository and have in there and check off as you go. So it's just it's a markdown file with a set of common themes which apply across all of those points in the earlier taxonomy. And then the other thing that I was finding a bit lacking in some of the other approaches to this was that the existing checklists were kind of, this is the minimum, right? Let's meet the baseline thing that we can do to get this. I didn't think they were very aspirational, right? They didn't have any kind of gradation to them. It was like, check this box off. But what can you do to go beyond the minimum requirements? What is like a better thing to do in your source control or whatever? There's a difference between just putting stuff in Git and there's basically one commit in the history and it's just you put it on GitHub to share it as your research project, as opposed to having an actual like Git commit history and then whether or not you've actually managed that history well so that someone can navigate through it and make sense of what the commits are. And even then you might go on to something like using conventional commits where you actually like have a machine readable commit history where you've got the like little prefixes where you can say this was a fix for something and so on. There's tiers of these things. And I have like a gold, silver, and bronze level at which you can tick all these things off. So the idea was there, can we gamify this like a little bit, right? So how can I sort of nerd snipe a bunch of people into doing like compliance stuff by making it a bit more fun and amusing to do and straightforward to just have in their repository?
That's awesome. What I like about the idea of having a checklist is it just makes it easier for researchers, right? So it says, hey, here's what you need to do. If you have a paper and you also have some code, just fill out these things and the science will be better. One of the main issues with doing open source in science is that it's extra work. It's difficult work because it's on top of what you need to do to be cited, right? It's on top of what you need to do to get your work out there. So when I think about the main reason not to do open source, it's just lack of time and lack of funding. How does your checklist help with that?
I suppose indirectly, in that if you're making your software outputs more citable, for example, then it's easier for people to actually cite the software that you used instead of just the paper. So you can get more academic credit, as it were, for the paper. The other thing that you can potentially do there is with credit, right? So increasingly, as you have more research technical professionals of one stripe or another doing the analysis work and generating that code, they can be given like prominent authorship positions on the code component of a paper or as a research output. And that can be part of their CV that is not necessarily just a citation on a paper, that maybe you're in the middle of the paper as a contributor to some of the analysis work, but you're at the top of the billing in the separate citable research object that is the code output. So there's sort of those kinds of dynamics to increase the value of code as a separate research output. The making it citable bit, I think, is important. You can then include a reference to the code in your methods effectively and refer to that as a separate supplemental but citable object. And then it ends up in all of the sort of citation metrics, machinery, and the graphs that can plot those relationships between things. So I totally agree with you that is a significant problem in the research space, in that we don't value these kinds of alternative and additional research outputs that are actually really important to the research being done as much as we value the sort of primary publications with which they're associated. My pitch to researchers on this is often along the lines of, you have your methods for your protocol stuff, your bench work, be a separately citable object. Have your data be a separately citable object. Have your research software be a separately citable object. Write up your paper in the form and format that is most sensible for its content, and then treat the publication effectively as a marketing exercise. Especially in like publishing in something like Nature, you have very little space to actually articulate what you did, but you have to have done an awful lot of work to even get published in Nature. Frankly, it's quite inconvenient to have to condense it into a very small space, and it does the work a disservice oftentimes. There are other places where you have a slightly more room to put in there, but the actual components of the work that demonstrate its quality to your colleagues and that make it more usable to your colleagues is oftentimes more in the way that you want it to be laid out than the way that the journals want it to be laid out. For the reproducible compute stuff, the data stuff, I often say, who do you want to be at the conference? Do you want to be the person whose data and whose scripts it took me like months to get running on my computer and figure out and reverse engineer how you had your tables or whatever, figure out all of the stuff that just wasn't documented well in your methods and your research output? Or do you want to be the person who was like, I hit one button and everything worked? So it's like reputationally in soft settings as opposed to in like the sort of hard academic metrics, I think it's really valuable to do this kind of work to make your research outputs more reproducible and more accessible to people, because the software tool that works great gets you a lot of soft goodwill in ways that just the high quality research paper might not.
I want to go back to the journals for a bit. You do make a good point that different journals have different editorial styles for how much you can cite, which is often a real issue with open source software, because we want to cite all the dependencies. You can't, or you can't cite 20 pages worth of dependencies. So don't you think it's an issue to make your data citable and your research data citable and your paper citable, when at the end of the day, one researcher is either going to have to cite just the paper or maybe the paper and the code?
I suppose it depends what you're doing with it, right? So, I mean, if I'm not really interested in the biological conclusions of your paper, but I'm using the method that you developed to do my own analysis, then maybe I don't need to cite the paper. I can just cite the tool, right? It depends on, I suppose, what exactly it is that I'm doing and what it makes most sense to actually cite. And one thing that I think you potentially gain from using research software for data publications and such is you kind of have like a recursive citation thing going on, right? So you cite the one item in the main paper, and then that cites a bunch of other stuff potentially without necessarily directly having to add to the citation count for your main list. So if you cite your record of your scripts and so on, but then your script has its own bibliography, which cites all the other stuff, then you kind of smuggle them in as secondary references.
In your field, is it the case that citation counts are more important or venue of publication is more important ultimately?
I'm not really sure. It's not something that I personally tend to pay a huge amount of attention to. I think if I had to gauge it, I'd probably say venue of publication carries a bit more kudos than citation count. But that may well be very variable by individual bubbles. There's a lot of cultural differences that are just very sub-discipline specific for these kinds of things. So not quite sure.
I think it matters though, right? Because if you're taking your code and you're making a separate citation, then people then cite the code instead of the paper. Let's say I publish in Nature, that would be great. But then my code is published on Zenodo and people cite my code on Zenodo. That's a loss for my Nature publication. How do you mitigate against that?
That's not one I can really solve straightforwardly, I don't think. That is a potential loss for the Nature publications citation count.
It's also a loss for science as a whole, right? Because you should be able to cite both. They should link to each other. They should cite each other. So
I always think about citations purely in terms of where did I get this information, right? For me, it's just the provenance of the information and what's the most relevant thing to cite. So the sort of citational politics bit has always been quite alien to my way of thinking. So it's a bit hard to emulate that I'll cite the Nature paper because it's the Nature paper rather than because it's the most relevant thing for the thing that I'm going to cite.
The human systems are inherently flawed, and I feel like they could be done better. We can't fix everything, unfortunately. Going back to InScope, you mentioned earlier that you wanted to gamify the system. So you built these checklists. They could also be thought of perhaps as best practices. So here's the best practice for doing this work, and sort of go through each of these sections, and that'll lead you to a more finished, more shareable, more usable, reproducible package as a whole. And you had this idea of having tiers. So you have silver, gold, platinum, large metals. Tell me about how you came up with these tiers and whether they have any correlation to the open publishing tiers that we've been seeing recently, like a diamond access, open access, gold, open access, etc.
I wasn't really mapping them to any of those particular other existing standards. They were basically just sort of a difficulty thing, right? So the bronze is intended to be, if you tick the bronze box, you've got your box, you've met the minimum requirements for it to be sufficiently reproducible. Whatever the particular theme or criterion is, you've passed the lowest bar. And in order to get sort of a bronze overall for the project, then you have to have a bronze in all the categories, as it were. So that's the approach I've taken with bronze. And then I've sort of had quite a steep difficulty curve on the rest of them. So silver and gold are relatively attainable. But if you've got platinum across the board on the checklist, then you're probably doing something wrong. It's actually a bit too much. And so unless you're an absolutely enormous software project with a very unusual combination of requirements, then getting to platinum in all the categories, I think, would be odd. It might be helpful for me to go over actually what the sort of general themes are, what the parts are for this checklist. So I've kind of split it up into these categories. So we've got source control, which is how you can keep track of the history of your project and how to collaborate on it. Then there's licensing. So on what terms can others use your code and how can you communicate this to them? Documentation. How do people know what your project is and how to use it? And then indeed how to contribute to it potentially. Making it citable. How should people make reference to the project and how should they credit your work? Testing, how can you test the project so you can be confident it does what you think it does? Automation, so what tasks can you automate to increase consistency and reduce manual work? Peer review or code review, so can you get third-party endorsement of or expert feedback on your project? Distribution, so how can people install or access the software that's coming from your project? Environment management and portability, so how can people get the specific versions of the software running on their own systems? Energy efficiency, so how can your users minimize wasted energy? And then the last one, but by no means least, is the sort of governance, conduct, and continuity section, which is how can you be excellent to each other, make good decisions, and continue to do so on an ongoing basis. More sustainability in a sense.
I like this. I think they're pretty good sections. There's a couple sections I'm not noticing. One of them might be how resilient is your software package to changes in geopolitical orders? Where is it all stored? Is it all stored at GitHub? Is it all stored somewhere else that's not in the US?
This I would very much put in the category of governance, conduct, and continuity, with continuity covering continuity of operations, including things like, did the particular repository that you're keeping it in go down in some sense? So yes, that's part of it. Although I think that actually also potentially relates to the environment management and portability section to some degree. The ability to reproduce your particular code environment is dependent to some degree on the tools that you pick to do your environment management. So if you picked something like Geeks, the functional package manager, they're the only software archive that I'm aware of that has their full source archive available through Software Heritage, and that's completely bootstrappable. So they can recompile everything from source, even if the original source repositories for the software that is in that environment go down. That would be one thing that would be a choice that you could make if you were trying to get some surety against GitHub going down.
What about things like community? So you could have a whole governance score here where it's just, I'm BDFL and that's how it's going to work. How do you deal with community stuff?
As I was kind of lumping that into that last category, it might need its own category, but it's one of the things that may or may not apply to the different parts of my taxonomy, right? So for the most part, you don't have a community of any particular size around like a one-off research output. You might do around a larger software project or even around an analysis pipeline, like the NF core pipelines are maintained by a sizable community of researchers doing gold standard bioinformatics pipelines. So that sort of sits under the governance continuity thing and would be a modification of it that applies to that particular category of list. So there'd be community-related stuff and what to expect in terms of maintenance and how to contribute to the project and so on in that section for the places where that applies. So basically everything but a one-off record.
So your three buckets, I guess, for research code is one-off, web-based service, and code intended to be reused. Did you base these on other definitions of research software, say from UKRSE or more broadly?
I read a bunch of other stuff about this, but there didn't seem to be an existing taxonomy that quite fit what I was looking for. So I more or less made that little grouping up myself. I think it may line up with some other definitions, but nothing else quite seemed to fit exactly what I was looking for. So I invented those three sort of broad categories, and then there's the subdivision in the reusable stuff between like a single software package and like a pipeline, because they have slightly different things that you might want to do for how they're tested and so on. There's a library for snake make pipelines for NF. Nextflow pipelines, there's NF core, but for software packages, you've got all the language-specific repositories like PyPy and CRAN and Cargo and all those kinds of things.
Tell me about the community behind the checklist itself. So you have your own website. You have it at rsspdc.org. And I know you have submitted a workshop somewhere that you're going to talk about this.
That was actually a couple of weeks ago. The Software Sustainability Institute Collaborations Workshop was in mid-May, and they gave me a mini workshop session there. I got some really good feedback on the checklists, and some of it I still need to integrate. But it's just been me pretty much working on this up to this point until I started getting feedback from other people. And that's kind of why I'm trying to talk to people about this more, get it in the hands of some other people to test it out and see if it actually, is useful for their use case. See if I've gauged the difficulty of certain of those things correctly, see if I've suggested things that make sense. There's still a couple of gaps in areas where I haven't quite filled in all the criteria that it makes sense to have here. So yeah, I consider this kind of very much in alpha analogy with software, right? It's the early testing phase. I'm sort of putting it out there to try and get some feedback on it, get some other people involved in the project, because I'd like to not be the BDFL on this. I'd like to have someone come along and join me in maintaining it, maybe be some kind of a co-author on a publication to write up some of this stuff, sand off the rough edges of my own opinions that may have edged their way into this, and get some more consensus representation about what the views are for these things.
So tell me how people can get involved.
So there's a GitLab repository, and there's issues open there. And of course, you can just email me. There's an email address associated with the project that's an alias to my regular email, or you can just email my work address. But yeah, like issues on the GitLab repository would be the easiest way. And that also means it can happen in the open and other people can join in that conversation.
Cool. I have a corollary question, which is kind of related, which is this work, again, as I said at the beginning, it takes a lot of effort. It's effort on top of your normal publication pipeline. It's on top of your normal code development pipeline. It's after you found your results, after you've written it up, then you need to make sure you go through and make sure your code is sound, et cetera. How can other people help you build a better platform? How can, say, the university or the research office or the library help you make this work better? Are there ways and tools that you're working on to help universities and research institutions in general enable this sort of work?
The main things in many ways that I think would be helpful to have intervention on to get more attention on this is to some degree actually at the level of publishers. perhaps to some degree at the level of funders as well, but where publishers often have policies about what the code accompanying a paper should be, their actual level of enforcement of these policies, on the other hand, is a bit lacking for the most part. So they don't tend to have people actually review for this kind of thing. It's not really emphasized very much. So if there was a bit more stringency and attention paid to some degree the existing requirements, but also potentially some modifications to those requirements for what sorts of things should be included with research software that accompanies publications, it's kind of underappreciated as a part of the methods for many modern papers, right? If you have a detailed step-by-step bench method, you need a detailed step-by-step code method. It's just that people perhaps are not necessarily paying as close attention as they could to the code side of things. I'm not sure. Maybe there's something to do with the demography of reviewers for these things. So perhaps you end up with more people focused on the biological questions or the domain-specific questions that are a part of the publication, as opposed to focusing a bit more on the methodological detail. And the people who are the domain specialists are also often the people who are specialists in the benchtop methods, but not necessarily the analytical methods. So the analytical part of a paper can be left a little bit to the side if it's not the primary subject of the paper, if it's just a piece of the method. So yeah, there's a bit of how review is managed, how editors think about what reviewers to pick and what emphasis to put there in policy. With respect to funders, I suppose there's an element of it's sort of less impactful at this level. It's more impactful in the sort of supply chain side of things as respect to sort of keeping things open, deciding to have policies about requiring certain amounts of openness from suppliers of equipment and so on, and of services would be nice from funders, because then you can get slightly stronger guarantees about the openness of the inputs to those things, right? And increasingly you see things like proprietary software associated with instruments and proprietary analysis platforms for the data that comes off of instruments. Long-standing issue with proprietary file formats, from everything from microscopes to mass specs, where if you could require at the very least that you have the sufficient technical specifications for these things that you could re-implement your own open source versions of them, even if you don't require the actual code or formats to be open source, at least the technical specifications necessary to do so without having to expend reverse engineering effort would be the minimum bar that should be set before funders should be willing to let you procure something.
So it's easy for funders to have stipulations for what people should do, but then they also have to fund that work. And I think my question was more about the people doing the work itself. Yes, editors can require stuff. Yes, funders can require stuff. What I'm asking is the coders and researchers who are doing this work, what provisions are in place to help them do it easier? And how are you enabling them to have that help? How can they lean on other people to make this work easier for them so it's not such a huge sink on their time?
Yeah, my function in the research consortium is to kind of take that burden off the people in the research consortium to the greatest extent that I can. So, when it comes to depositing a data set or depositing a code base in Zenodo or in the image data repository or whatever, I will help out with people doing the metadata annotation, understanding what the requirements are for those particular domain-specific data repositories and so on. So that is still to a degree a thing that the funders have done because they pay my salary. So I'm available as a resource to take the burden off the researchers in my consortium who have to do this kind of stuff. And I can provide sort of educational resources and do some of the administrative work associated with this stuff. But in terms of individual researchers' choice to do this, it's pretty much up to them, right? Do they want to use these kinds of indicators as a signal of the quality of their work? If I'm looking at a piece of research that has sort of no transparency associated with how it was done, even if it's published in fancy high impact journal, if it doesn't have good transparent methods, if it doesn't have open code, I'm highly skeptical of its conclusions, and it goes down significantly in my evaluation of it. So there's an element of almost like a costly signaling theory to it, right? You expend a bunch of additional resources to demonstrate that you are doing integrous science, which is transparent and open, and people can see how you did what you did, which does cost you, but it demonstrates that you did in fact do that. And in a research environment where we have increasing numbers of cases of people who have been discovered for committing research fraud, you see these cases now, right? That it's surprising really how many have come up of late. So being able to signal to other researchers that you are in fact being transparent in what you do, I think is increasingly valuable as a signal. about the quality of your work that is independent of the sort of old school reputation system of prestige of the all publication venue, around how many times a thing is cited. It's like, how open is it? Is, I think, a really important thing to strive for.
How do you mimetically signal that you have followed this checklist? Do you suggest that people put it in the acknowledgements of their paper? Hey, we followed this. Or is there some other way that you can say, this is the checklist I followed?
There's a repository badge that you can whip up to put on the README file of your repository. The idea would be that you might want to stick the checklist file in your repository, and then as you make changes to your code base that allow you to check a box on the checklist, you put those in the same commit, as it were. So then you've got the history of the change that you made associated with the checkbox action. So you can see the file being present in your repository, and you can put a badge on it that has the number of points that you got for ticking the different boxes and the little bronze, silver, gold sort of indicator. That's one of the things that you can use that might acquire some signaling value if people start to adopt it.
Is there a way to grade other people's work and say this is only a bronze grade or something?
That is an interesting one. So the dynamics of whether or not you do a self-assessment or whether or not you ask other people to do an assessment is an interesting proposition, right? So you might be able to request a third party do this. At the moment, I don't really have any sort of resources to set up something like CodeCheck or whatever to be someone who could go down and give you a third party rundown of the checklist. So it's kind of self-assessment at the moment. But getting someone else in your research group or someone else who knows something about the sort of software side of things, so someone at your institute who's bioinformatics or an informatics core facility or whatever, who might be interested in using this kind of thing, could potentially score a project for you with a software-informed lens on the question.
Have you taken this to the chaos people, the people who work on metrics for open source?
I have not, but that is a good suggestion. I may attempt to do so.
I think that would be really great. Also, I mean, the obvious thing for me, because I used to have a consultancy that ran checklists for repo health, is having someone be paid to do that work and then having funders pay that person to make sure that work is done for everything. But of course, that depends upon people with big pockets and convincing them to put some of those pockets into your pockets, which is always really tough.
So I wouldn't really know who to apply to that, to get a funding for that kind of thing for. So it might be, it'd be an interesting thing to, if anyone knows anyone who is interested in funding that kind of thing, let me know. And then I can reach out to them and maybe I can do some kind of a grant application and see if I can get something like that funded.
Good luck. No one's jumping to mind right now, but I think it is possible. And I think this is pretty cool work. We are running up on time. So you can find this at rsspdc.org. Anywhere else where we can find you or this work, Richard?
richardjacton.net. My work email there, my personal email's there, my Mastodon handle and so on. That's all there. Just richardjacton and fostodon.org.
You can also, of course, find these links in the show notes, which you can find at podcast.sustainoss.org. But don't leave yet. At the end of every single podcast, we have a spotlight where we highlight other people, projects, or things that we think need a bit of light shed on them. My spotlight today is just rather silly. I just really like Birds NZ, the Ornithological Society of New Zealand. I am fresh off the boat, or plane as it were, coming back from Auckland, where I attended the Birds NZ annual conference, and I just had a really great time. It was just super fun to hang out in a room filled with bird nerds, and then go to Tiritiri, which is an island off of Auckland, and see saddlebacks and tieke and kokako off the beach. Oh, what bliss! So Birds NZ doing great work, tons of stories of people doing conservation and making sure that those species even exist today. If you're in New Zealand or if you're in any country, find your local ornithological society because they're really just a bunch of people who just want to talk about cool living things. That's basically the best. Richard, what's your spotlight today?
I'm just thinking about all the New Zealand birds now. The ones in the UK are great fun, but the New Zealand ones, I think.
That's me all the time. Yeah, they're quite fun here. I'm not going to wax poetic, but what's your spotlight?
So my spotlight pick is the RIX package for R, which is a straightforward way of setting up an R environment using the Nix package manager and the sort of broader community of R in Nix. In particular, the work that Bruno Rodriguez does in that community is always very energetic, and he was very helpful when I kind of did a bit of a drive-by contribution to RIX to add a basic functionality for converting from RENV lock files to RIX descriptions in sort of imperfect fashion. But that's a really nice tool for anyone who is familiar with R and wants to dip their toes into Nix as a bit of a less steep introduction to the famously steep learning curve that is the Nix ecosystem.
Cool. Richard, thank you so much for coming on. It was really cool to talk about this initiative, this checklist. I hope that they continue to grow and be used. That would be super, super cool. I also hope that part of that growth pattern comes from this podcast. If you've listened to this podcast, listeners, you know what's coming up next. It is the ask for you to share and talk to people about this podcast. Tell people to listen, tell people to follow along. You can follow us on LinkedIn and Spotify and Apple and Mastodon and all the social networks and places where podcasts are bought and sold and or given away for free, as is the case here. As this is given away for free, but it's not free to produce, it'd be really awesome if we could have more funding for this podcast. So do go to opencollective.com/SustainOSS and donate. I will be setting up tiers at some point this week. So by the time you listen to this podcast, you will be able to be a tiered subscriber and or funder, which would be really, really cool. You can also go to podcast.sustainoss.com or .org, one of them, to look at the show notes and to find the notes and to follow along with this and also to see the other podcasts in our history. If you have any thoughts, you can email me, richard@sustainoss.org, and yell at me, send love notes, I don't know, whatever you want. And of course, you can find Richard Acton at richardjacton.net. Richard, thank you so much for coming on. This was really, really great. Best of luck.